Welcome to the series on linear equations. In this video we're going to talk about the process and some definitions to do with linear equations. So first of all we'll review some common terms, and then we'll talk about some basic algebraic manipulations, look at some norms to solving equations, and just put those norms into a really simple context. So let's look first of all at some definitions. So I'm going to go through some definitions based on a particular equation. So let's say we had this equation here. 3x plus 2 is equal to 8. Now that would be considered a pretty simple equation. So first of all, a term, a coefficient or a constant. These are naming terms, and I'll define them each individually now. A term is a piece of an algebraic equation that is separated from all the other terms by either an equal sign or addition or subtraction sign. So as you can see in this equation above, there are three terms. The three terms are 3x, 2 and 8. A coefficient of a term is the value in front of the unknown, the pronominal. And in this case, the coefficient of x is 3. A constant term is purely numerical. And in this case, both 2 and 8 are constant terms. Functions versus equations. You'll also need to know about functions versus equations. A function typically relates two or more variables and is sometimes called a relation. An equation, on the other hand, will be solvable. So an equation will be something that you can solve for the unknown values. In this case, this is an equation because we can rearrange and we can solve for x. You may be asked to rearrange, to substitute, or to solve. And you'll need to know the difference between these three things. There are other terms that you may need to use in an algebraic situation, but these will be the important ones for this topic. You may be asked to rearrange. In terms of an equation, this is where we move the terms and maybe remove coefficients in order to solve the equation. But rearrange also relates to functions. So in a function, you may rearrange to make some other unknown the subject of the function. You may be asked to substitute, in which case you're usually given or can work out the value of an unknown, and you'll remove the unknown and place that value in its place. If you're asked to solve, you are being asked to rearrange an equation to get the unknown by itself, and that will help you calculate what it's equal to. So to solve is to work out what the pronominal, the unknown, is equal to. And of course there is some words that I've been using that I should also bring your attention to now. So I've talked about pronominal, variable and unknown. At this stage, consider these three to be pretty interchangeable. They all represent or name an unknown value in an equation which we typically use a letter to represent. Now let's consider some of the norms associated with solving equations. So let's go back to the equation we've just been talking about, which was 3x plus 2 is equal to 8. Now in this equation we have three terms. 3 is the coefficient of x. There is only one unknown, that's x, and our goal here is to solve the equation to calculate the value of x. Now you may find you already know the value of x, and it's a reasonably simple equation, but I want to talk about the norms associated with this question. Usually when we're solving x, we're trying to rearrange it so that x is equal to some number. So typically we'll try and keep x on the left hand side, but we don't have to, and I'll show you an example of that in a moment. What I always say is aim to keep x on the side where it will remain positive. Now again, you don't have to do that, but it will eliminate any issues you might have with negative numbers and possible mistakes that come about due to that. So at the moment x is positive here, so I'm going to leave x on that left hand side of the equal sign here, and I'm going to start to unwrap x. So imagine x is like a gift at Christmas and it's currently wrapped up in things. The first goal here will be to get the x term by itself. So by that I mean the 3x, so that's the x term. I want to get the 3x by itself. So I'm going to remove the 2. This 2 is my issue. So to remove the 2, I'm going to subtract 2 from both sides. And I come out with 3x is equal to 8 minus 2. So 3x is equal to 6. Now, I've removed the 2 and I've got myself in a situation where the x, the only x term, is by itself on one side of the equation. Now I need to remove the coefficient. And so in this case that is the 3. To remove the 3 times x, I'm going to divide by 3. And that will of course give me x is equal to 6 divided by 3, which of course is 2. Now at this stage you may choose to resubstitute the 2 back in to the original equation here, so that you get 3 times 2 plus 2, and that of course gives you 8, which means that you have done the correct thing. So in this example we're talking about 14 is equal to 5x minus 1. Again, in this case I'm going to try and get the 5x by itself. So the first thing I'm going to do is add 1. At the moment it's 5x subtract 1, so I'll add 1 to fill that subtract 1, which will cause it to cancel out. Now writing this out in full, I get 14 plus 1 is equal to 5x minus 1 plus 1. You probably don't need to show this level of working, but it's a really good way to get your head around and understand what you are doing. You're doing the same thing to both sides of the equation, which means they're still equal. This one and this one cancel out, and it leaves us with 15 equals 5x. And of course we've achieved our goal of having x by itself, or the 5x term by itself. And now I'm going to divide by 5 to remove the coefficient. And I'm left with 3 is equal to x, which means of course that x is equal to 3. So again here I have started with the 5x minus 1 equals 14. I've kept the x on the side that keeps it positive, and I've worked through that process of getting the x term by itself and then removing the coefficient to get the value of x. See you in video 2.